Good morning, everyone. In the previous class, we have covered the energy, the types of energy. Okay, so we will take 5 minutes revision on this, revision on that part, and we'll move to the next. Okay, so we will tell the types of energies. Fatapat, will not wait much.
Internal energy and external energy.
Yes, internal energy and external energy. Okay, so in the internal energy, we have seen the different types. So who will tell types of energies under the category of internal energy? Go ahead fast.
Chemical energy, atomic energy, molecular.
Yes, chemical energy, atomic energy, and molecular energy. Okay, one by one definition. Who will define chemical energy?
Can I, sir?
Yes, go ahead. Go ahead fast. Define
It
chemical
is
energy.
the energy released due to the changes in chemical composition.
Energy released due to change in chemical composition. That is the chemical energy. Next, atomic energy. Next, who will tell?
Can I, sir?
Yes.
Can I, sir? It is energy released due to changes in atomic structure of matter.
Yes. Energy released due to changes in atomic structure of a matter. Good. Next, molecular energy from girl side.
The energy due to molecular motion and its configuration is called the molecular energy.
Okay. The energy released due to its molecular motion or the configuration is referred as or is known as molecular energy. Good. Next, under the category of external energy, we have seen the two types. Boy side, So tell the types.
Potential and kinetic.
Potential
Energy and kinetic energy.
Potential energy and kinetic energy. Correct. So who will define kinetic energy?
The
Boys.
energy.
Can I, sir?
Oh, no.
Can
The
I, sir?
turn is towards boys. मुलामध्ये सांगा कोणतं?
The energy possessed the body give to its position is known as potential energy. It can be calculated by PE is equal to mgz.
Yes. Potential energy is nothing but the energy possessed by the body due to its position is referred as or is known as potential energy, and it can be calculated by the formula MP is equal to mg into z. Correct. Next, kinetic energy, girl side.
Can I, sir?
Yes.
The energy possessed by the body due to its motion is known as kinetic energy. It
Correct.
can be calculated by the formula Ke is equal to half mv square.
Okay, K is equal to 1 by 2 half mv square. Correct. The energy is possessed by the body due to its motion. Correct. Then we have seen the I think control volume and control surface, right? Later we have seen control volume and control surface. So quickly tell the definition control volume. Wise, please tell the definition of control volume. What is control volume?
The volume of a system remains constant. It has a fixed position is known as a control volume.
Correct. When the volume of a system remains constant and it has a fixed position is known as a control volume. Next, control surface, girls. Girl side control surface. Fast.
The surface surrounded by the control volume is known as control.
The surface surrounded by the control volume is known as control surface. Correct. The surface surrounded by the control volume is known as control surface. Okay, good. Then we have come to the point that is properties. No, up to control surface we have written points.
System of state of system.
State of system.
Yes. What is state of system? मुलीमध्ये सांगा कोण स्टेट ऑफ सिस्टम सांगेल? Hello.
The exact condition of a system that describes thermodynamics properties is known as state of system.
Okay, ठीक है. The exact condition of the system that will describe the all the thermodynamic properties known as state of a system. Good. Now, after that, I think we have written the heading properties of a system.
Yes, sir.
Yes. So I think we come up to this.
Yes, sir.
Okay. So very interesting. This point is there. Normally, those students are belong to mechanical engineering. They may find the question in the gate examination based on this concept. They can make it 5 star for this concept. Intensive properties and extensive properties. तुम्हाला गेट परीक्षेमध्ये याच्यावरती प्रश्न विचारला जाऊ शकतो. तर त्याच्यामध्ये they will give the examples, or on that they will ask, is it intensive property or extensive property? So you should be able to select the correct property. Okay. So properties that we have defined, like it's a observable or measurable characteristic of a system. Okay, observable or measurable. So you want to measure it, you can measure with the help of different instruments, or just observe by your naked eyes. Such properties, such a characteristic of a system is known as properties. Then after that property, then the properties can be divided into two types. One is intensive properties and extensive properties. Okay. So one by one we will discuss what is intensive properties. Anyone? What is intensive properties? How you can define intensive properties?
Can I, sir?
Properties do not depend on mass of system.
One second. Let me know. Ha, bola. Go ahead. आता सांगा तुम्ही काय ते सांगा. Aditi.
The property which do not depend on mass of system.
The properties which do not depends on the mass of a system. Very good. The properties which are do not depends on the mass of a system. Such properties are known as intensive properties. Good. Second, extensive properties.
A property which depend on amount of matter.
Yes. The properties which depends on a amount of a matter is known as extensive properties. Good. See, very if you understand the definitions of intensive and extensive, it will be very easy for you people to view examples. Mention the examples under the intensive category and the extensive category. Okay, I'm going to give the homework for you people to prepare a table, and you can prepare a table. 3 columns can be made. Serial number, intensive property, second column, third column will be extensive, and in that you have to write the number of examples. So that exercise I will give for today. So as you mentioned, intensive property, it is do not depends on the mass of system, or you can say independent on mass of a system, is known as intensive properties. So who will tell the examples? बघा, डेफिनेशन तुम्ही असं सांगताय की ती प्रॉपर्टी मासवर डिपेंड नाहीये. अशा प्रॉपर्टीज की ती मासवर ती डिपेंड्स नाहीत, इंडिपेंडेंट आहेत. Such properties are called as intensive properties. So can you tell the examples of such properties?
Temperature, pressure, density.
Temperature, pressure,
Density.
Surface tension,
surface tension,
viscosity,
Boiling point.
boiling point,
melting point,
melting point.
specific heat.
Many properties you can add later in the homework, no problem. Such properties are comes under the intensive properties. Okay, then extensive properties.
Weight.
Weight,
Mass, volume.
mass, volume. Okay, these are some extensive properties. Okay, तर तुम्हाला मी लॉजिक सांगणार की हाऊ टू अंडरस्टँड, हाऊ टू डिफरन्शिएट इंटेन्सिव्ह प्रॉपर्टी अँड एक्सटेन्सिव्ह प्रॉपर्टी. जर तुम्ही जर डायग्राम तुम्हाला दिसते का स्क्रीन सर्वांना?
Yes, sir.
Yes, sir.
हा, इथं मी सुरुवातीला एक बॉक्स वरती टॉपला एक बॉक्स आहे बघा, मास, व्हॉल्यूम, टेम्परेचर, प्रेशर आणि डेन्सिटी. ओके, देन that box is divided into 2 compartments. Okay, that box is divided into 2 compartments. राईट, लेफ्ट साइड आणि राईट साइड. याच्यातनं काय दिसतंय क्लिअर होते आपल्याला? कोण सांगेल? वरती प्रॉपर्टीज मेन्शन केलेत पहिल्या जो काही मेन बॉक्स आहे तो त्याच्यात पण तुम्ही 2 पार्टिशन्स केले. ओके, त्याला आपण ए पार्टिशन, याला म्हणू बी पार्टिशन. I will call this as a A and this is B. यातनं काय कळतंय तुम्हाला? Anyone? वरती वरच्या बॉक्स मध्ये तुम्हाला प्रॉपर्टीज मेन्शन केलेत, मास, व्हॉल्यूम, टेम्परेचर, प्रेशर, डेन्सिटी. आणि खाली काय केले त्यांनी, तेच त्याची जरा मांडणी वेगळी वेगळी केली आहे बघा. यातनं काय सुचतंय की व्हॉट इज द कन्क्लुजन हियर?
एक्सटेन्सिव्ह प्रॉपर्टी बदलतात, त्यांच्यात मास बदल केल्यानंतर पण इंटेन्सिव्ह प्रॉपर्टी बदलत नाही.
करेक्ट. तुम्ही किती पार्टिशन टाका, properties values will be remain same in each compartment. ओके, जर व्हॅल्यू त्याची जर सेम राहत असेल, तुम्ही किती जर कंपार्टमेंट केले तर त्याची such properties are known as intensive properties. आणि जर तुम्ही अशा प्रॉपर्टीज की ज्याचं तुम्ही डिव्हायडेशन केलं, म्हणजे त्याला कंपार्टमेंट केलं, तर त्याचं व्हॅल्यू बदलत आहे. ओके, त्याला असं म्हणू की द प्रॉपर्टीज can be divided, it is possible to divide it. Such properties are known as extensive property. The properties which we cannot divide it. Are you getting? Such properties are known as intensive property. आता बघा ना, टेम्परेचर घ्या. ओके, आता टेम्परेचर तुम्ही, हे रूम आहे बरोबर आहे का? पहिल्या सुरुवातीला आपण एक रूम्स कन्सिडर करूया. हे रूमचे जे काय टेम्परेचर इनिशियली आपण बघितलं, समजा 30 डिग्री सेल्सिअस आहे बरोबर. परत तुम्ही त्या रूमचे 2 पार्टिशन तयार केले. मग टेम्परेचर इथलं ए मधलं आणि बी मधलं सेम असेल का वेगळं असेल? सेम ना,
सेम असेल.
कारण जी रूम मेन रूम आहे त्या रूमचं तुम्ही मग फक्त मध्ये पार्टिशन टाकलेलं आहे, बस, बाकी काहीच केलेलं नाही. सो टेम्परेचर विल रिमेन सेम. म्हणजे डिव्हायडेशन शेक काय घेतं? इट इज नॉट पॉसिबल टू डिवाइड ना. प्रॅक्टिकल डिवाइड करणं सोपं आहे का? नाहीये. त्यामुळे काय झालं, इट इज इंटेन्सिव्ह प्रॉपर्टी. तसंच प्रेशर ऑल्सो नॉट पॉसिबल टू डिवाइड इट. सो इन ए कंपार्टमेंट व्हॅल्यू विल बी एस व्हॅल्यू, बी कंपार्टमेंट व्हॅल्यू ऑल्सो विल बी रिमेन सेम. सो इट इज अ इंटेन्सिव्ह प्रॉपर्टी. डेन्सिटी इज मास अपॉन व्हॉल्यूम. ओके, so this rho means density. It will be remain same in the both the compartments. Value will be remain same in both the compartment. It is intensive properties. Now again, if I take surface tension, melting point, color, etc. are the intensive property. बघा ना, ह्या रूम मधला कलर ह्या रूम मध्ये काय बदल झालाय का? सुरुवातीला तुम्ही एकच कन्सिडर केले ना, त्याचं परत पार्टिशन टाकलेलं आहे. मग इथला कलर आणि इथला कलर बदलणार आहे का परत? No. So such properties are known as intensive properties. Okay, but mass and volume, if you see the mass, it is divided here, half kg, volume half. So this is divided. Okay, so we can say such properties are called as extensive properties because they depends on the mass, size. Okay, the properties which are depends on the mass or a size of a system or matter, or somebody said the properties which are depends on the matter. Okay, matter म्हणा किंवा mass म्हणा, काही फरक पडणार नाही. Mass or a size of a system is known as extensive properties. तर मला वाटतं हे लॉजिक सर्वांना कळलं असेलच. कळलं का? हॅलो.
Yes, sir.
Okay. Shall we write down these points?
Yes, sir.
Okay, write down. Property definition लिहिले आपण. Definition.
Yes, sir.
प्रॉपर्टीची डेफिनेशन लिहिलेली आहे. ओके, नेक्स्ट. नंतर मग पुढचं लिहा. द प्रॉपर्टीज कॅन बी डिवायडेड. द प्रॉपर्टीज कॅन बी डिवायडेड इंटू 2 टाइप्स. हे लिहिले का वाक्य?
No, sir.
Okay. The properties can be divided into two types. First, intensive properties. Second, extensive properties. Extensive properties. Intensive properties. Second, extensive properties. Now, number one, intensive properties dash. We will write the definition. Intensive properties dash into double inverted comma. The properties which are independent on mass of a system. The properties which are independent on mass of a system. Mass of a system. Independent on mass of a system is known as intensive properties. Intensive properties. ग्रामेटिकल येस पाहिजे आर पाहिजे तिथे येस नको आर पाहिजे आर नोन एज इंटेन्सिव्ह प्रॉपर्टीज कारण एक प्रॉपर्टी बद्दल आपण जर बोलत असेल तर फक्त येच येत असते आर नोन एज इंटेन्सिव्ह प्रॉपर्टीज the properties which are independent on mass of a system are known as intensive properties. For example, temperature, pressure, etc. Temperature, pressure, etc. Temperature, pressure, etc. Next, second point, extensive properties. Dash into double inverted comma. The properties which are depends on mass or size of a system. Are known as extensive properties. What you said?
Repeat.
Okay. The properties which are depends on mass or size of a system. Are known as extensive properties are known as extensive properties. आता काय लोक म्हणत असेल की सर आता तुम्ही डेन्सिटी जी प्रॉपर्टी आहे ते व्हाय यू आर कॉलिंग एज इंटेन्सिव्ह प्रॉपर्टी, बरोबर आहे का? आणि डेन्सिटी मध्ये जर विचारलं तर आपल्याला स्टँडर्ड फॉर्म्युला माहित आहे, डेन्सिटी इज इक्वल टू मास अपॉन व्हॉल्यूम, बरोबर आहे का?
Yes.
बरोबर. So the reason is that if you see the formula of density, I will mention here, we will understand why it is a intensive property. Density rho, I will try it. Density rho is equal to mass upon volume. Okay, mass is extensive property, correct?
Yes.
Baga formula. Mass is extensive property, volume also extensive property. If baga condition, if the ratio of two extensive properties, that properties is known as a intensive property. दोन extensive properties चा ratio तुम्ही घेतला, so that ratio is a intensive property. लक्षात ठेवा. जर extensive property numerator ला extensive property, denominator ला extensive property, तो जो काय आहे ती जी काय quantity असेल that will be a intensive property. So you can write a note, ratio of two extensive properties, ratio of two extensive properties is known as intensive property, full stop. For example, density.
Can you repeat the definition?
The ratio of two extensive properties, the ratio, not a definition, it is a note point. Ratio of two extensive properties is known as intensive property. मग आता मी अजून एक टर्म सांगतो, स्पेसिफिक व्हॉल्यूम. इज इट intensive or extensive? Specific volume. It is extensive. बरोबर. I'm using the word specific volume. Specific volume ला आपण intensive property. It is intensive property. बघा कसं आहे, specific volume. What is formula specific? इथं लिहायचं लगेच, लक्षात ठेवा. Specific volume. ओके, असं फॉर्म्युले पहिले लिहायचे, त्यानुसार मग आपण परत डिवायडेशनचा वगैरे रूल अप्लाय करायचा. स्पेसिफिक व्हॉल्यूम इज इक्वल टू 1/ρ. बरोबर आहे का? Am I right?
Yes, sir.
If I want to calculate specific volume, how you can calculate? 1/ρ, na? 1/ρ means what? 1 upon density. Rho is nothing but density. Okay, then what is the formula for density? Mass by volume. मग काय होईल? V by M होईल का नाही? बरोबर आहे का? डेन्सिटीचा फॉर्म्युला काय, मास आपण व्हॉल्यूम. व्हॉल्यूम वरती जाणार न्यूमरेटरला, काय होईल, स्पेसिफिक व्हॉल्यूम इज इक्वल टू, याला आपण स्पेसिफिक व्हॉल्यूमला स्मॉल व्ही म्हणतो. स्पेसिफिक व्हॉल्यूम स्मॉल व्ही इज इक्वल टू कॅपिटल व्ही डिवाइडेड बाय मास एम. ओके, आता बघा, व्हॉल्यूम इज एक्सटेन्सिव्ह, मास इज ऑल्सो एक्सटेन्सिव्ह. द रेशिओ ऑफ टू एक्सटेन्सिव्ह प्रॉपर्टीज आपण नोट केले बघा. रेशिओ ऑफ टू एक्सटेन्सिव्ह प्रॉपर्टीज आर नोन एज intensive property, are known as intensive property. आता सेकंड कन्क्लुजन मिळालं आपल्याला इथं. लिहा मग सेकंड कन्क्लुजन काय आले, all specific properties are intensive properties. All specific properties are intensive properties. All specific properties are intensive properties. Got it? तर मी जे दिलेलं जे तुम्ही अशा नंबर ऑफ प्रॉपर्टीज तुम्ही ते ऍड करा आजच्या एक्सरसाइज मध्ये. सर्वांना कळालं का सगळे?
Yes, sir.
ओके,
Yes, sir.
random question for the exercise, today's exercise or homework. enlist the properties, काय लिहिलं, enlist
The properties.
चुकतंय का त्यात क्वेश्चन? एक्झाम्पल म्हणूया का आपण, enlist the examples for intensive and extensive properties. Enlist the examples for intensive and extensive properties. Intensive and extensive properties. ओके, मग कसं करणार तुम्ही, पहिल्या कॉलम मध्ये सिरियल नंबर, दुसऱ्या कॉलम मध्ये इंटेन्सिव्ह प्रॉपर्टीज, तिसऱ्या कॉलम मध्ये एक्सटेन्सिव्ह प्रॉपर्टीज. मग त्याची एक्झाम्पल त्या ठिकाणी लिहायचे. कॅन यू डू दिस एक्सरसाइज टुडे?
Yes.
Yes, sir.
ओके, यू कम्प्लीट
Yes,
इट अँड
sir.
यू कॅन शेअर ऑन माय व्हॉट्सअप. ज्यावेळेस तुम्ही सेंड करता त्यावेळेस माझा रिस्पॉन्स येतो सर्वांना?
Yes, sir.
ओके, एखाद्याचा आन्सर जर चेक केलं तर मला फोन करा सर, बरं का? ठीक आहे. नेक्स्ट पॉइंट विल डिस्कस टुडे, that is thermodynamic equilibrium. Give the heading, thermodynamic equilibrium. Thermodynamic equilibrium. Give the heading, thermodynamic equilibrium. Now, thermodynamic equilibrium. When we say system is in thermodynamic equilibrium, that we'll understand first. Okay, when the system is said to be a thermodynamic equilibrium when it fulfills the following requirements, such as thermal equilibrium, chemical equilibrium, and mechanical equilibrium. Okay, when it fulfills the requirements like thermal equilibrium, chemical equilibrium, and mechanical equilibrium, if all these three conditions are satisfied, then we can call the system is in a thermodynamic equilibrium. Okay, आपण सिस्टम जे आहे, जे काय तुम्ही सिस्टम स्टडीसाठी घेतलेले आहे, ते इक्विलिब्रियम मध्ये आहे की नाहीये कसं करणार तुम्हाला, जर त्या तिन्ही कंडिशन जर सॅटिस्फाईड असतील, थर्मल, केमिकल आणि मेकॅनिकल, तरच तुम्ही म्हणाल की बाबा the given system is in a thermodynamic equilibrium. So we can start experiment and we can get the results, right? So what are those equilibrium that I have told now? Mechanical, chemical, and the thermal equilibrium. Okay, so one by one we will see the definition of the thermal, chemical, and the mechanical. So firstly, thermal equilibrium. What is thermal equilibrium? Anyone? When we say system is in thermal equilibrium, system thermal equilibrium किंवा thermal equilibrium मध्ये आहे असं कधी म्हणणार तुम्ही?
When all parts are the same temperature.
Yes. When whatever the system you consider, in that system, temperature if you measure at each point, okay, or each part, it will find same. Okay, it will find same. Then only we can conclude that system is in a thermal equilibrium. Okay, good. This is point. Next, mechanical equilibrium. When we call system is in mechanical equilibrium, once again, who will tell?
Can I, sir?
Yes.
The pressure remains constant during the transformation.
Yes, when pressure does not changes, okay, it will remain constant. Then we can say system is in mechanical equilibrium. Okay. Azun, chemical. When we call system is in chemical equilibrium, when there is a no change in chemical composition or no any spontaneous chemical reaction takes place in a system. So then and then only system will remain in a chemical equilibrium. त्याच्यामध्ये कुठल्या प्रकारची रिएक्शन घडता कामा नये किंवा कंपोजिशन मध्ये बदल होता कामा नये. जर तसं जर झालं तरच आपण काय म्हणू शकता की system is whatever the present system is in a chemical equilibrium. Okay, so in mechanical equilibrium I will add one word here. As you mentioned, pressure will remain same. At the same, you can say in another way also, when there is no any kind of unbalanced force, when there is no any kind of unbalanced force exists between system and surrounding. कुठल्याही प्रकारचा अनबॅलन्स फोर्स जर नसेल तर तुम्ही काय म्हणाल, सिस्टम इज इन अ मेकॅनिकल इक्विलिब्रियम. आता फॉर एक्झाम्पल तुम्ही बघितलं पॅन बॅलन्स, एका साइडला तुम्ही वेट ऍड करत असता, दुसऱ्या साइडला थिंग्स असतात, वस्तू असतात. एक ठिकाणी ज्यावेळेस पॉइंट ऑफ झिरो डिफ्लेक्शन दाखवेल, then only we can say it is in a perfectly, means whatever the weight is there, it's perfect weight and equilibrium can be achieved. So that is what the mechanical equilibrium. बरोबर आहे ना एक्झाम्पल हे. आपण मेकॅनिकल इक्विलिब्रियम अचीव झाला असं कधी म्हणणार? बेस्ट एक्झाम्पल पॅन बॅलन्स, राईट? सो राईट अबाउट दिस. First, write the definition for thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium. In thermodynamic equilibrium,
Sir, repeat करा.
A system is said to be in thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium when it fulfills the following requirements First, thermal equilibrium. Second, chemical equilibrium. Chemical equilibrium. Third, mechanical equilibrium. Mechanical equilibrium. ओके, आता पहिली डेफिनेशन लिहा थर्मल मध्ये काय असते, राइट. फर्स्ट, थर्मल इक्विलिब्रियम डॅश. थर्मल इक्विलिब्रियम write down. A system is said to be, a system is said to be, a system is said to be in thermal equilibrium, in thermal equilibrium, in thermal equilibrium, comma, when temperature of a system, when temperature of a system, temperature of a system, temperature of a system remains constant, remains constant, remains constant, or does not changes, or does not changes with respect to time, with respect to time. So next, chemical equilibrium. Second, chemical equilibrium. A system is said to be in chemical equilibrium. A system is said to be in chemical equilibrium, in chemical equilibrium when there is no change in chemical composition, when there is no change in chemical composition, when there is no change in chemical composition and no chemical reaction takes place, and no chemical reaction takes place.
Can you repeat?
A system is said to be in chemical equilibrium when there is no change in chemical composition, there is no change in chemical composition and no chemical reaction, no chemical reaction takes place in a system. No chemical reaction takes place in a system. Full stop. In a system.
Composition च्या पुढून सांगा सर.
No change in chemical composition and no chemical reaction, and no chemical reaction takes place. No chemical reaction takes place. Chemical reaction takes place in the system, in the system. And the last equilibrium is mechanical equilibrium. A system is said to be in mechanical equilibrium. A system is said to be in mechanical equilibrium when there is a no change in pressure. There is a no change in pressure. There is a no change in pressure at any point. At any point of the system. At any point of the system. Or there is a no unbalanced force. Or there is a no unbalanced force.
Can you repeat, sir?
A system is said to be in mechanical equilibrium when there is a no change in pressure. There is a no change in pressure at any point of the system. At any point of the system. Or there is a no unbalanced force. Or there is a no unbalanced force exist between system and surrounding. System and surrounding. System and surrounding. System and surrounding. तुम्हाला काही डायग्राम्स पुढे दिसतात बघा. त्याच्यामध्ये मास दिलेला आहे 2 kg, टेम्परेचर 20 डिग्री सेल्सिअस, V1 1.5. त्यानंतर खाली क्लोज सिस्टम रिचिंग थर्मल इक्विलिब्रियम. क्लोज सिस्टम रिचिंग थर्मल इक्विलिब्रियम बिफोर आणि आफ्टर. ओके, टेम्परेचर वेगळे होते ज्यावेळेस ते सगळे एकत्र आणले त्यानंतर मग टेम्परेचर सेम झालं सगळीकडे, इक्वल टेम्परेचर. ओके, ते सगळं बॅलन्स झालं सर्व. तर या पद्धतीने हे आपण इक्विलिब्रियम कन्सेप्ट म्हणजे यू कॅन अंडरस्टँड. ओके, I hope you are clear with this question or the concept of equilibrium. Thermodynamic equilibrium, in that basically 3 types needs to be understood: thermal, mechanical and chemical. Okay, बाकीचे बरेचसे types of equilibrium आहेत, but we are interested in the 3 types, so we will cover that only: thermal, mechanical and chemical equilibrium. Okay, now we'll move next. Put the heading. Next, thermodynamic processes. Thermodynamic processes. Thermodynamic processes. Okay, so when we say thermodynamic processes completed, or when how you can define process, thermodynamic process? कौन सांगेल? Anyone? Thermodynamic process. We'll draw one diagram here. Can tell.
It is the process which brings change in the state of the system.
Yes. No. It is the process. No, we want to define process. तुम्ही काय म्हटलं? Just repeat. What you said? Can you repeat? Hello. Repeat करता का please?
The process which brings change in the state of the system.
The process which brings the change in state of the system. Okay. थोडस आपण मांडणी जरा वेगळ्या पद्धतीने करूया, म्हणजे कारण आपल्याला प्रोसेस डिफाईन करायची. बघा मी दाखवतो डायग्राम मध्ये. बरोबर, कन्सेप्ट तुमचं बरोबर आहे. फक्त डेफिनेशन मध्ये मांडणी करताना आपण जरा वेगळ्या पद्धतीने करूया. वन टू. ओके, आता इनिशियली सिस्टम कुठे आहे? स्टेट 1 ला आहे बघा. समजायला ते काय करते? स्टेट 2 ला जाणार आहे. मग त्याच्यामध्ये काही इंटरमिडिएट स्टेट्स पण असणार आहेत ना? असणार की नाही? नसणार आहेत?
असणार आहेत.
येस. When system undergoes change of state, when system undergoes a change of state, okay, that is nothing but a process. That is nothing but a process. म्हणजे सिस्टम एका पॉइंट पासून दुसऱ्या पॉइंट कडे जाण्यासाठी ओके जे काय होते that is nothing but it is a process. It is a process. It is a thermodynamic process because in this change of states the properties are going to change. The properties are going to change. If you consider pressure volume diagram, PV plane, त्याच्यामध्ये प्रेशर चेंज होणार आहे, व्हॉल्यूम पण चेंज होणार आहे. सो दॅट इज व्हॉट when system undergoes change of state, it is nothing but a process, or you can say a process is said to occur when system undergoes a change of state. A process is said to occur when system undergoes change of state. Can you is it right statement now?
Yes, sir.
Yes. When process undergoes change of state, that is the process. So, or system undergoes change of state is nothing but process. Okay. Write down. A process is said to be occur. A process is said to be occur. A process is said to be occur, comma, when system undergoes a change of state. A change of state. System
Sir,
under-
repeat करा.
A process is said to be occur. A process is said to be occur, comma, when system undergoes a change of state. System
Sir,
undergoes.
repeat करता.
Okay. A process is said to be occur. A process is said to be occur, comma, when system undergoes a change of state. System undergoes change of state. मग हे ग्राफ काढा. Show this graph. आपल्याला आपण आहे process 1 to 2. You can say as a process 1 to 2. लिहूया आपण असं 1-2 process. One dash 2 is the process. ग्राफ काढा, ग्राफच्या जवळ घ्या. 1-2 process. Okay. You give the attendance. Roll number 1.
Present, sir.
2. Roll number 2. 3.
Present, sir.
4.
Present, sir.
5. Roll number 5, 6, 7, 8,
Present, sir.
9,
Present, sir.
10. Roll number 10, 11,
Present, sir.
12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15, 16,
Present, sir.
17. Roll number 17, 18,
Present,
19. Roll number 19, 20. Roll number 20, 21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41, 41, 42,
Present, sir.
43,
Present, sir.
44,
Present, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present, sir.
50,
Present, sir.
51, 51, 52,
Present, sir.
53, 53, 54,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59. Roll number 59. Last number is 59, na? Sure, sir. Roll number 59 ka?
Yes, sir.
Yes.
Okay, I will repeat absent numbers once again. Please concentrate. Roll number 2, 5, 6, 10.
Sir, 6 present.
Okay. 10, 15, 17, 19, 20, 41, 51, 53, 59. These are absent. Okay. We conclude meeting here. Thank you very much.